So your midterm test, I'm still grading on it. So it should be done by tomorrow. So I will post the key once I finish grading the test. How do I grade your test? I can show it to you. Example. So you guys know, and then also help me to check for any arithmetic mistakes I make, like adding and subtracting. So let's say this is your test. So if you have, if you see a checkpoint, means that is correct. Okay. If you see me putting wrong on it, means that is wrong. And usually when you see a wrong, I will always put a -2 or a -half, means that's how much point I will take it off. And then on the side corner on your every page here, it should be a total of all your negative points. So let's say this is a total of -2.5. So this is -2.5. And then so I will do the same thing on every page. Let's say this is 0. 0 means you get all the whole page, right? And let's say this is -3, let's say. So what I do is at the end, I will add all these negative points, -3 plus 0 plus -2.5. This is -5.5. So I will put somewhere here that is in your total. It's out of 60 and you got 5.5. So it will be 54.5 out of 60 minus 5.5. So this is what you will get in your test. This is your total grade for your test here. So if I make any arithmetic mistakes, like, I add something wrong, or I give you, I did do that. Sometimes I make mistakes by adding your points. So if I do have mistakes, you have to let me know by emailing me. Say, hey, David, I should get 55.5, not 54.5, because you add something wrong. So I do have a few of those mistakes. So please let me know if I make mistakes here. So again, I should finish grading your test by tomorrow. So make sure you guys check the work, okay, that I did. Anyone have any questions? I also post a key once I finish grading your test. So make sure you look at the key and figure out. And for the multiple choice, as a lot of people get wrong, my key has all the methods. That means it will show you all the ways to do your work here. Okay. So so today we start chapter 7 here. So there's no homework due tonight because your homework, you got 2 weeks off. So we will start chapter 7 here. We call estimating parameters. So this is talking about confidence interval in chapter 7. And then in chapter 8, we do what we call as a hypothesis testing. So we will do your next test will be your finals. So you don't have your midterm and your finals. Your finals is going to be in May something. It's in the syllabus. Go check the syllabus. I think it's like the 2nd week or 1st week of May. It consists of chapter 7, 8, 9, and 10. So you got 4 more chapters left. I think if I add correctly, 2, 3, 3, 2, 6, you got only 10 homework left. So these 4 chapters have 10 online homework. Chapter 7 has 2, chapter 8 has 3, chapter 9 has 3, and chapter 10 has 2. So you got 10 total online homework left. So it's not a lot, but the homeworks are getting difficult. I'm going to point out to you, you got only 10 homework left for the end of semester, but your homework is difficult because the material recovery here is going to be very tough. So just so I would recommend you to rewatch the Zoom meeting here if you need help. So this last 4 chapters is what we call as inferential statistics. What is inferential statistics is we try to make predictions, inferences about the population parameter. So we always take sample from a small sample size and we study the sample, and then with that sample, we always make prediction about the population parameter. There are 2 population parameters that we will talk about in this case. Either we do population mean or population proportion. So in this chapter 7, 8, 9, actually these 2 chapters, we will concentrate on mean and proportion. There are a lot of other parameters, but we didn't talk about, like standard deviation, median, variances, and all those things that you learn in chapter 3, all the mean, median, mode, all those things. But in this class, we only concentrate on 2 parameter, which is the mean and the proportion. So that's the reason why when you do your homework, sometimes you got two sections. Is because one section is about proportion, like 7.1 is about proportion, and then 7.2 is about mean. Same thing happens in chapter 7, 8, and 9. We all will talk about one section is proportion, and then one section is mean in this case. So what we do in this case is the inference statistics. In chapter 7, we talk about estimating a population parameters. This estimating estimating values of population parameter is what we call as confidence level, the confidence interval. You see this a lot when you see in the news, like for example, from the last election, you find out that people who vote for Democrat is 48% plus minus 4%. So that the plus minus 4%, this is what we call as confidence interval. That is where we will be using this a lot in chapter 7, and this is very important. Again, I will tell you what how do we find these numbers. Okay, and then the chapter 8, we talk about testing hypotheses. When you test hypotheses, usually you have a claim statement. So in the questions, you have to read the question very carefully, and it does have a claim statement. And usually the claim statement is about the population parameter. So is the population mean or population proportion? So so when we talk about 7.1, we are talking about population proportion. So a lot of students have no idea what is the meaning of proportion. So proportion means decimals. So or probability or percentage. So when you guys do my test, when you do your homework, it's easy because 7.1 is all proportion, 7.2 is all mean. You can figure out, oh, this is proportion, this mean. But when you do my test, it's all mixed up, proportion and mean. So you need to figure out which one is proportion and which one is mean. It's very easy to figure it out. Is proportion. Usually we have decimals. Usually I want in percentage. Usually I use the word proportion, probability. So those are regarding with population proportion. Another thing that we talk about population proportion is usually this is for categorical variables. Does anyone remember what are categorical variables? Anyone give an example of a categorical variables? You guys here today?
Slowly starting to come back, sorry.
So anyone know what's the categorical variables?
Like, I'm just guessing, but would it be like, I'm not guessing, but I'm trying to figure out, like, I don't want to say jersey numbers on shirts or anything like that, but.
Nope, that's not categorical variable. Good try. Those are not. Category variables is where you got categories and you pick one of them. So that means you got choices and you pick one of the choice. That is categorical variables. For example, gender. You got male, female, and so on, non-binary, all those things. So you only pick one of those. So that is category variables. Like your party affiliation, like Democrat, Republican, Greenhouse, Independent, so on. You only pick one of those. Any color, like eye color, hair color, color of skin, yes, no, yep, yes, no. So anything that you know, do you have a tattoo? Do you smoke? Do you drink? So on. So yes and no. If you have any yes or no, that is also category. So anything that has categories and you only pick one of them, that is called categorical variables. And this is used a lot. This is used in proportion. So when you look at the example in this case, like this example is asking for a medical malpractice lawsuit. So either this is talking about if you know, like suing the nurse or doctor or hospital, either you feel innocent or you are guilty. So, you know, categorical variables. Example like this is talking about voting for the election. Either yes, you go vote, or no, you did not vote. Okay. This is talking about M&M candies. So there are colors, that green, yellow, orange, and all these colors. Yellow, I don't know. So there are colors. So they are categorical. So that's why you find out this whole when you talk about proportion, chapter 7.1 is all about categorical variables. But when you talk about 7.2, when we talk about population mean, this is quantitative variable. Can someone give me an example of a quantitative variable? No, the word quantitative. Anyone? Teresa,
numbers? Something with numbers?
Yeah, so what variable we usually measure with numbers? Yep, you're correct. Numbers is correct, but give me a variable that is for it. Like your height.
Height. Yeah, I was gonna say height, weight,
test score, temperature. So those are all about numbers, as what you mean. Is quantitative variable. So this is the one that you do in the next section. So if you look at 7.2 homework or questions, so this is about mean. This is talking about number of chocolate chips in your cookies, which is numbers. This is talking about birth weights, which is mean. And this is also talk about how much caffeine you have in the soda. Okay. Now, I just want to point out to you guys that a lot of students, when they do the test, not your test, your test, I'm going to show you what happens to your, not this one. Oh, sorry. So just for the heck of it, so you guys know what is going on in your test. So your test will look something like this. So like this question 1. If you read question 1, there are some keywords that you need to know. Can someone read question 1 and tell me the keyword I'm looking for here? I'm sure to you what's the keyword I'm looking for here. So again, this is what you do when you do my test, my finals. The first keyword is the word confidence interval and the word percentage. Those are the keywords I'm looking for. This, if you read this belongs to what? Percentage is the same thing as what? Mean or proportion? Is this the same as your mean or proportion?
Proportion.
Yeah, so this is about proportion. And when you see confidence interval, this is 7.1. So all the chapter 7 is confidence interval. How about question 2? I want you to read question 2. What is the keyword that I want you to look at?
Confidence interval again and percentage.
Yep. So this is also the same as the first one. Okay. Now, when you now read question 3, what is the keyword for question 3?
Is it confidence interval and mean?
Yes. So if you got this keyword, confidence interval and mean, this is 7.2. How about question 4? Confidence interval and
Mean.
So this is also 7.2. So this is the thing, class. This is why it's so difficult in your test, is because you have to read the question so carefully. And if you did not pick up all these keywords here, you are done. I can tell you that. Now, question 5 is special. So let's read question 5. Do you see the word confidence interval in this question?
Significance level in mean.
Yes, very good. Who was that? Linda, thank you. So when you see significance level and mean, it's not the same thing as confidence interval and mean. So this section, when you do confidence, when you have a significant level, this is chapter 8.3. Okay. So this is when you do significant level, this is doing what we call as a hypothesis testing, and which will be in chapter 8. You learn, and this is about and this is for cannot spell today. This is for mean in this case. Anyone? Let's read question 6. Do you know why I'm teaching you this? Is because in your finals you are doing all this, and if you pick the wrong one, you get 0. And doing a hypothesis testing is a 10 to 12 points. And if you get wrong, you get no points. You lose at 10, 12 points. That's why I want you guys to read the question very carefully. So read question 6. What is a keyword for that?
Level of significance.
Very good. And also the word hypothesis testing. So you know this is about hypothesis testing, not confidence interval. But is this mean or is this proportion?
Is it proportion because it's percentage?
Thank you. Yes, because of the percent you see here. So it is proportion. So this is actually 8.2. Okay. You guys got what I'm trying to teach you guys here? This is proportion, yes. You guys all right? So make sure you read the question really carefully, because sometimes it's very, so these are the keywords. So I don't know how many of you print out the test and do the midterms, but in the finals, I really want you guys to do this, because I don't think so you can highlight this in your test paper, right? In your computer screen. So if you print it out, at least you don't highlight, you can have you have your pencil or pen, you can underline those keywords. So make sure these are the stuff that you are looking for, and really class, the chapter 7, 8, 9, 10, your midterm, your finals here is going to be all word problems like this, and you are looking for all these specific keywords. And if you just miss one keywords, you probably will be getting the question wrong. Okay, so now let's talk about 7.1. So this is talking about proper confidence interval for proportion, probability, or percentage. Yes, those are the keywords. So the first thing we're asking for is the best point estimate. So if you remember, in Democrat, I say 48% plus minus 4%. You see this a lot in the TV, you know, in the news. This 48% is what we call as your best point estimate. Okay. Okay. This 48% is what we call as the best point estimate. And this 4% is what we call as margin of error. So how do we figure out this 48%? This 48% is actually comes from your sample proportion p-hat. So the sample proportion p-hat is the best point estimate of population proportion. So this 48% actually came from the sample. For example, if I ask this class, you didn't raise your hand or tell me, how do we find this best point estimate for the Democrat for this class? Is I just ask you guys, how many of you guys are Democrat? So let's say you do not just do anything. Let's say in this class I got 25 students, and out of these 25 students, let's say 18 of you guys are Democrat. Okay, so example. So how do you find this sample proportion? So in order for us to find this p-hat, the sample proportion, you just take x over n. What is x? X is the number of students who are Democrat, which is 18, out of 25. So if you use your calculator, 18 over 25, that number is your 0.72. Yeah. Okay. So this is the same thing as 72%. So this is your best point estimate. So it's not 48 anymore, it's 72 based on this example. Okay. So this is how you figure out your best point estimate is you take the sample proportion. And how do you find the sample proportion? You take the number of people, or we call it X, which is the number of success, over by the sample size. Okay. For example, here is in the research center, 70% people, 70% of 1501 believe in global warming. So what is the sample proportion in this case? So your sample proportion in this case will be 0.7 or 70%, either one is fine. Again, I'm not picky with your homework, with the test, but your homework, make sure you read the question carefully. If the question says, I want this in 2 decimal place, then your answer is 0.7. But sometimes your homework will say something like this with a percent next to it, then you will need to put 70%. So this one means your answer has to be in percent. You guys clear with me? With your homework?
Yeah.
So you have to read the question very carefully. If you see a percent, don't put 0.7, they will mark you wrong. So since 70% of 0.7 is a sample proportion, then what is the best point estimate for this case? So as you know that the best point estimate is your sample proportion p hat. So in this case will be 0.7. Okay. So this 0.7 is your sample proportion, and that is also your best point estimate. Okay, or 70% depends on. So once you get into a confidence interval, a confidence interval is usually given us by this 72% plus minus 4%. So it's a range of values that used to measure to estimate the true value of a population parameter. So again, there are keywords for this case. The keyword here is this true value of the population parameter. You also need to know how to interpret this confidence interval. So can someone tell me, if I give you 72% plus minus 4%, what is the range of this? This is something like range or rule of thumb, right? So what is 72% plus minus 4? What is the lower and your higher limit, upper limit? Anyone know how to figure out your lower and upper limit?
You said 72 and oh, and the 4 up there. Okay, yeah.
Yep, 4 is, I say 4 is the margin of error. So how you find your lower, you just subtract these two, right?
68.
That will be 68%. And what is your high?
76.
76. So in your StatCrunch, they will give you these two numbers. Okay. And this is what we call as what? The confidence interval. Okay. And what is this 68% to 76%? This is actually the range of the values to estimate the population parameter who vote for Democrat. So what is going on in this case, class, is if I got this result, 72% plus minus 4%, that means that when the election comes, the population, the people, all the people who vote for Democrat is between 68 to 76%, which in this case is really high. So if I'm Democrat person, I'd be happy because I know this is a good number for me. But usually when you go election, it won't be that high. Okay, usually in the between 40s and 50s. Okay, so so this is the meaning of it. But some students will ask me, is this really true that everyone vote for Democrat is between those two numbers? Then I say it has a confidence level. What is a confidence level? A confidence level is what we call as a degree of confidence. That means how confident are we with these numbers? This is actually the probability of getting this parameter, getting this population parameter assuming that we repeat this in a large number of times. So usually we use a 95% confidence level here. So what is going on in this case is if you say this is the percentage of people who vote for Democrat for all the Americans, not just this school or this class, then I will say this is actually 95% confident. So when I say 95% confident means that there is still 5% error. You guys with me here? And this 5% error is what we call as alpha. And if you remember alpha, this is what in your review here, this is called the significant level. Okay, so you see the significant 0.05. So this is also called significant level. Okay, so so that's the reason why that if I give you 95% confident, you still have a 5% error. So that means that what is going on here is, let's say I collect this class. This class, we know the percentage of Democrat and or Republican is around 50%. So mostly, if I collect the first sample, your confidence interval is going to be around 50%. Let's say 47% to 53%. If I collect and then I go out and collect another sample, and this sample is going to be very close, let's say 46 to 51%. So if I collect these 100 samples, okay, 100 of this, 95 of this will capture this 50%. And why 95 is because that's a 95% confidence. Okay, that means that there are 5 samples that is not in here, like the one we have 68 and 74. So that will maybe they are either very high or maybe they are very low, 32 and 36. So there are only 5 of this chance, 5 of this out of 100 will be not capturing the 50%, but the rest of that 95 of this will capture the 50% out of 100 samples if I collect that. So this is the meaning of the word 95% confidence. And this 95% confidence can be changed to 90%. It can be changed to 99. It can be changed to 85. It depends on the question. 95 is the most that we use. Okay, so that's why when you look at the questions that we did here, this is talking about 90%. This is talking about 99%. This is talking about 95, 98. So this is the so make sure you read the question very well. What percent they want you. So so that is the meaning of a confidence level. So how confident are we getting this this confidence that the population parameter falls into these numbers? Okay, so again, class, if I use 95%, the alpha, which is a significant level, is 5%. Okay, can someone tell me what happens if I use 98%? What is the alpha in this case will be? If I use 98%, what is the alpha in this case will be? Hello, class. Are you guys here today?
2.
2% or 0.02. So make sure you guys know. Yep. In your StatCrunch, we always want decimals. So don't put 98%, put 0.98. Okay. So make sure you guys know the difference here. Next is interpreting. So as you know that in your finals, you also allow 1 page, front page of all your whatever you're going to put in there. So I would really highly recommend you to put this in your how we interpret the confidence interval is all this. Okay, so this is how we interpret the confidence interval. So how do we interpret, if I got this 68 to 76, how do we interpret this? Is we are 95% because we're using 95%. That the interval from 68%, don't forget the percent, to 76% does contain the true value of the population proportion P that voted for Democrat. Spell again. Is it E? Yeah, I think so.
How did you get 0.02?
This one
Yeah, 2.
is the opposite of 100 subtract 98.
Oh, okay.
That's how you get the 2%. Mhm. So this is the very important interpretation. So if you guys, this is where you're going to put this in. So this fill in the blanks is what you have to do, and these are the whole thing is important. So if you guys do your online homework, you are looking for this word. Okay. You do not need to worry about the second interpretation. This one we don't use a lot, so do not worry about that. These two ways are incorrect ways. So please, if you have to do your online homework, do not pick this. You cannot say we are 95% chance to get the value of P that falls between 68% and whatever the percent we have and 76%. This is no good. Why this is no good is because of the word chance. We don't use the word chance here. We use the word what? Confident. So that's why you have the word confident here. Okay. Another way that is wrong here is 95% of sample proportion will fall between 68% and 76%. This is also wrong. The reason why this is wrong is because of the word sample proportion. It should be true value of the population proportion. This is the word that you have to put in there. So that's so make sure you guys know this is wrong here. Just be careful with this. So do not use this, because in your test, I will ask you to interpret the confidence interval. If you use the word chance and if you use the word sample, you won't get full points. Questions with this? You will see the homework. You will figure out what's going on. Next is the critical value. So
I have a question.
Yep.
When you were doing the example on the other sheet, I was a little confused at what exactly you meant by the 95% in there.
This
in
one?
your other
This one?
In the drawing sheet.
Drawing. Oh, this
Yeah.
one?
Yeah.
Yep.
Can you explain that part again, please?
So when you have a 95% confidence, means that if I pick 100 samples, 95 of them will capture the true value of the population proportion. That means that 5% of this, because the total should be 100, that means 5 of them will not capture it. Now we know that when you talk about Democrat, Republican, or yes, no, or male, female, usually 50% is what the number is. So majority of the time when I select 100 samples, 95 of this will capture 50%, like 47 to 53. 50% is in there, right? 46 to 51, 50%. And if I collect the third sample, it will be also capturing 50%. So if I keep on collecting this, 95 of this sample will capture this 50%. However, the 5 of them will not capture this. That means that the number is either above this 50 or below this 50. You know what I'm saying, Cecilia?
Okay.
So that's the meaning when I say 95% confident, means that out of 100 samples, 95 of them will capture this 50%. Only 5 of them will not capture.
Okay.
So that means
so that confidence level, is that something that's going to be given to us all the time?
Yes, yes, yes.
Okay.
This confidence level is always given to us. And if it's not given to us, then we will use 95%.
Oh, okay.
So
Okay,
if
thank you.
yeah, you can tell they're all given to you. See, they're all given to you, all the percent confidence interval. See that? 98%.
Okay, got it.
98%. Yep. In the same thing in your homework, they will give you the percents. Mhm. Now, next thing we talk about is critical value. What is a critical value? A critical value is a borderline that's separate between significantly high, significantly low with no significant. We use Z alpha over 2, okay? And so again, what is alpha? Alpha is that opposite of your confidence level. So if I have 95%, alpha is 5%. If it's 98%, alpha is 2%. So what is the critical value here is the critical value is where you figure out that at one point, the cutoff point, this is a critical value, that this is your significantly high, this is your significantly low, and this is no significant. So this cutoff point here is what we call as your critical value. Okay, this is very important, is because anything falls inside this is considered no significant. Anything falls like like your range of rule of thumb. Anything falls outside those is low and high. So that's the reason why that you need to know how to find the critical value. In order for us to find your critical values, you go to stat, calculus, calculator, normal, mean 0, standard deviation is 1. Make sure you put 0 and 1. That's why. And then when you go on the second box, make sure you put greater than or equals to. This is the question mark, is the answer. And then make sure equals to alpha over 2. This alpha is your, if it's 95%, you use 0.05. If it's 98%, it's 0.02. Make sure you divide this by 2. The reason why you divide this by 2 is because you got two-sided here. So this 2 is alpha. So if this is 95%, then this 2 has to be 5%. Because the total is 100%, but we're only concentrating usually on 1. And how do we find this is you take the 5% divided by 2. That's why your alpha is divided by 2, is because it's half of it. And I will tell you that whatever number you get here, let's say it's 1.5, your critical value. This critical value is exactly the same, but it's going to be negative. Okay, so that's the reason why that when you guys use to find a critical value, you divide this by 2 is because you got two-sided here. And then once you find one of this, which is always a positive answer, the other one is always the negative of it. Okay. And this is what we call as a critical value. Okay. I will show it to you how you use your StatCrunch to do it. Margin of error. The margin of error is that plus minus sign. Okay, the one that we did, the plus minus 4%. So the margin of error in this case is E, so capital E, is a maximum likelihood of the difference between the observed sample statistics and the true value of the population parameter. So what is margin of error is the most maximum of the difference between what is the sample between the sample and the population, the maximum of the difference. So in order for you to find the margin of error, you do multiplying the critical value with the standard error. But you do not need to worry about this, because if you do look at the videos I post in YouTube, you know, those videos I call you to watch, they will use this, which is this formula. This is a formula that the E is where you take Z alpha over 2, which is a critical value. The standard error in this case is square of P hat Q hat over N. This is a formula to do it, but you do not need to use this. What you need to do here is, in order for you to find the margin of error, you just need to take the upper limit, because your StatCrunch will give you the upper, and minus the lower limit divided by 2. So that is the most easiest way for us to find your margin of error. So please do not use this. Okay, you only use this when you don't have StatCrunch. But if you have StatCrunch, use this. This is the easiest way to do. So there are few notations you need to know. So again, this is something I will recommend you to put in your little cheat sheet, as I remember. So P in this case is your population proportion. Cannot spell today. P hat. So make sure you know the difference between P and P hat. P hat is your sample proportion. So if I get you from sample from you guys, then the proportion is P hat. Population proportion is P. This is usually when I talk about all, the whole group. Okay. N in this case is your sample size. How many do we have? Like 25 students and 80 students. X in this case is the number of success. So if I'm talking about Democrat, then X in this case is the students who are Democrat. If I'm talking about girl, then X in this case is number of girls in this class. Z alpha over 2 is what we call as the critical value. So these are the few notations you need to know because we'll be using this and it will be the same thing in the next section. In order for us to use your finding your confidence interval in 7.1, you have to go through these 3 requirements. So the first requirement is to be simple random sample. How do we know if the first requirement is fulfilled in your when you read the homework? Is you have the word random. This is a big keyword here. So if you hear the word random, it's good. Okay. Next, it has to fulfill the binomial distribution, which means that there are four conditions here. It has to know n. It has to be independent. It has to be 2 categories, and the probability are constant, the same. Constants means same on each child. Means that if you talk about boy and girl, the probability of you getting boy and girl is 50-50. And then the next case, boy and girl, is also 50-50. The next case is 50-50. This is the meaning of constant. And the last thing is, the third requirement is it has to be at least 5 success and 5 failures. That means that when I'm talking about 5 success and 5 failures, if I'm talking about boy and girl, that means I need to have at least 5 boys and 5 girls. At least means 5 or above. If I'm talking about Democrat and Republican, means I need to have at least 5 Democrat and at least 5 Republican in the classroom. So I cannot be all Democrat and only 2 Republican or the other way around. Then this requirement will not be fulfilled. Okay, so these are the 3 requirements. So if you fulfill all these 3 requirements, then we will able to calculate the confidence interval that we have. However, if one of these requirements does not fulfill, then you cannot calculate this. So, but if you're doing this in my test, if this requirement does not fulfill, you still need to calculate the confidence interval. You guys with me here? So I just want to put a note here. So in the real world, if one of these requirement does not fulfill, you stop. However, in your test, you have to continue. Because you are just starting with this class. This is a basic statistic class, so that's the reason why that there are another ways for us. If one of these requirements does not fulfill, we have to go through another way. But since you guys in the beginning statistics, so if this requirement does not, one of these requirements does not fulfill, you have to continue. Continue means you have to continue doing that. Okay. Rounding, I'm not picky, 2 or 3 decimal places as what you do. So same thing in the test. So when you round 2, 3 decimal places. So how do you do this in your StatCrunch? This is very important. So in your StatCrunch, you go to Stat, Proportion Stats, 1 sample with summary, and click on the confidence interval. And usually in StatCrunch, they will ask you for N. Oh my God. And they will ask you for X. And they will ask you for the confidence level. Okay. So I'm going to give you an example here. Okay, so let's look at some example here. So this is the StatCrunch. So you go under stats, you go under proportion stats, one sample with summary. So this is what you need to go. And if you click on it, they'll ask you for number of success. So number of success means how many people are, in the example, Democrat. How many we have just now? I just give you an example here. By the way, is this all in D2L class? This notes?
Yes.
Yes, so you can actually, you do not need to copy it, it's all in D2L. I think last time I used how many students? 25 students, 18 are Democrat, right? So I can do that in my, I can find a confidence interval here. So 18 are Democrats out of 25 observations. Now we do not, if you look at this, there are two choices. We do not do hypothesis, we do confidence interval, and we use 95%, so 0.95. Okay, a lot of students put 0.05, that is wrong. We are not doing alpha here. So please use back 95 or 99 or 89 or whatever the question wants to do. So don't use the alpha in this case. And when you hit compute, and you get yourself the lower and the upper limit. So this is the lower and upper limit. And if you look at the sample proportion, this is your best point estimate, 72%. So we got that before already. This is 72%. Oops, sorry, wrong notes. Remember the 72% that we got last time? The p hat that we divide. Your R actually, your StatCrunch actually will calculate here is under sample proportion. And then the lower and upper limit is your limit. So in this case, by looking at your StatCrunch, your lower limit in this case is 54.4%. So if I use this example, this is given us by 54, I'm gonna put it here, 54.4%. If I want to change the percent to what? 89.6%. Okay, so this is the what we call as a confidence interval, and we know 72% is your p hat. Do you know how to find your margin of error, E? Remember how you find your margin of error, E?
The upper limit minus the lower limit times 2.
Divided by 2. Divided by 2.
Divided by 2.
Yep, non times 2. So upper limit is 0.896, right? Minus the lower limit, 0.544. And then divide this by 2. So everyone take out your calculator and find the margin of error for me, given this. Anyone got an answer?
0.176.
0.176. You guys good? This is easy calculation, right? It's not that. Okay, so you guys all right here so far? So it's not too difficult actually. If you, I mean the StatCrunch. If you don't have StatCrunch, you will cry. If you look at all the examples from the YouTube video that guy do, it's gonna take you 1 page long to do it, to get these numbers, okay? But StatCrunch will help you. So there are 3 ways for us to write your confidence interval. Your StatCrunch is always given you this way, which is they give you the lower and the upper limit. That's why, you know, this one and this one. So they got, this is usually the StatCrunch. You can also write this in this way. So how do you write that in that way is you can write this as 54.4% less than P less than 89.6%. So you can also write in this way. So in a test, I don't care what way you write. You can write in the first way, which is the StatCrunch way, which I will ask you, which I will suggest you to do it. Or you can write in the other way, which is the just put a P in between. Or you can write in this way, P hat plus minus E. Now, what is P hat plus minus E? P hat is your your best point estimate. And by looking at your StatCrunch, your p hat is 72%, this one, 0.72. So you can also write this as 72% plus minus E. And E is the margin of error that you just calculate here, which is 17.6%. So there are 3 ways for you to write your answer: 1, 2, and 3. Online homework, you will see what they want. If they want it in this way or that way, that they will tell you what way. But in my test, I don't care what way you do it, but I really strongly suggest you to do the first way, because that is the one in your StatCrunch. You guys clear with me? Okay, so next thing we talk about here is if the question did not give you the 72%, okay, you can also find this p hat, we call it p hat, by taking, last time we take what? The upper minus lower divided by 2, right? This time you just take your upper plus lower divided by 2. So if the question did not give you p hat, you can also figure out by upper plus lower divided by 2. So again, upper is 0.896, and lower is 0.544, and then you divide this by 2. And if you use your calculator, this came up to be 72.72. Okay. So my question to you is, how many ways can we find p hat? So in order for us to find sample proportion p hat, there are 2 ways to do it. One is doing x over n, where x in this case is your number of success, n is your sample size. Or you take the upper plus the lower divided by 2 if you know your upper and lower limits. Or in StatCrunch, you look at what? Where's the StatCrunch? You look at sample proportion. Okay, so in StatCrunch, I put SC. You look at your sample proportion. You guys okay here? Tough? All right, let's give you an example here. So this is the confidence interval for population proportion. It's between these 2. Can you tell me how you find, I want this question in form of p hat and E. So can someone tell me how you figure out p hat here? What you do?
Upper plus lower.
Upper plus lower divided by 2.
Yep. Can you guys do that with this question? This is your upper. Don't forget the big one's the upper. This is lower. So go take out your calculator and add and divide by 2.
.25.
Everyone good with 0.25?
Mm-hmm.
And how you find E in this case? Which is right here. You can.
Upper minus lower divided by 2.
Yep, upper minus lower divided by 2. So go ahead and try to do this. See again your upper and lower divided by 2.
0.071.
0.071. So what is your answer in the form of p hat plus E? Your answer will be 0.25 plus minus 0.071. Okay, so p hat is this one and E is this one. And that's how you figure your answer. You guys all right here?
Yeah.
Okay, so these questions are very similar to, where is my homework here? So let's take a look at your homework. And we can, this is not too tough actually. All right, a magazine provided that a pool of 1,500 adults, and out of the 1,500 response about your favorite pie, 11% choose chocolate. The margin of error is plus minus 3%. So what is the margin of error plus 3% in this case? So the question is asking for the margin of error, right? So what is the plus minus statement that the study is -3? No. So we include the true population percentage. Contain the true. Okay, which one is the correct one? I know A is wrong because usually when you have margin of error, you have plus minus. This is not good. Anyone?
Let's see.
So indicates that true pot is not, is that likely or is that, so it's either C or B, D. I think it's this one. I think it's D. Let's look at the notes for confidence for margin of error. Margin of error is the maximum likelihood for this case. I think it's, let's try D. I think it's D.
D.
I think it's D. Okay. Because why we say that it's a likely is because there is a chance that it's not in this range. Okay. Don't forget that, remember the 95%. So only 95% chance will be caught in here. The 5% is not catching up in there. So that's why the word likely is used here, because we are not 100% confident. Okay. So we never find 100% confidence. We want to do 99, 98, 95, and so on. So that's why that is not always 100% in this case. I think this one is the same question. Question 2. This is about which one is wider. Okay. So you got 1500s like pi, 40% same thing. Which one is wider, 95% or 80%? Now this you need to pay attention here. So in order for us to figure out which is wider, so let's say you have a 95% and 95% is between 0.3 and 0.4 example. If you want to do 100% confident, it's going to be 0 to 1. What I mean by 0 to 1 is 0 to 100. So if I want 100% confidence, I don't need to calculate 0 to 1. Okay. If I want 99%, this number is, this wide will be wider, maybe 0.2 to 0.5. If you want 95, 0.3, 0.4. If you want 80%, this is getting smaller, 0.35 and 0.38. So what happened is that the higher your level, the wider the confidence. Okay, so this is a conclusion we will need to make. So if you have a higher the confidence level, the wider the confidence it gets. Okay, so in this case, which one of this is wider, a 95% or 80%?
80.
Again, the conclusion is if you have a wide, if your level is getting up,
95.
so 95. So which one is bigger, 95? So 95% is wider than 80. So it's either A or D here, because it contains 95% of truth, while the 80%. Yep. So this is the right one.
Can you explain that why 80%?
We can, yep,
You-
I can
you
use an
pull that,
example
okay.
here. Yep, I can use an example. So this is what we do for 95%, right? So this is an example we use, right? So 95%, your confidence is 0.544 and 0.896, right? So I'm going to change this to 99. So what happens when I change this to a 99%? then this is going to be
Okay.
0.488, 0.951. So this is actually wider, right?
Mm-hmm.
And then if I change, I can also change this to what, 90, because so for 90, you find out that this is actually is smaller, 0.57 something and 0.8. So it's always like that. You figure out that if this is this is always true. So the higher the level is, the wider your confidence level is.
Oh, okay.
Interval is. Yep.
I mean, that
Because
makes
if you want more confidence, you want it bigger. The more confidence you want, the more, so you can capture it better. Okay. So that one is, I think it's A. Yep, then it's D then. Sorry. Didn't read this question really good. Yeah, I think the more higher the confidence, the more you can capture it. Point out to you that more important thing is make sure you know how to find the wide which one is better than 95. So in the that will be this kind of questions will be asked in your multiple choice. I will say which one is wider, a 95, an 80, an 85, and a 99. I give you 4 choice. So you pick which one is wider. You know what I'm saying? So in the multiple choice, you will get 4 or 5 percentage. And I will say, you do not need to explain why, you just need to tell me which one is wider. Now you need to find this critical value. So in order for you to find the critical value, the formula to find your critical value is this formula. This is the formula to find your critical value. So you have to use your R. So first thing first, if I give you 94%, you need to know alpha. So what is alpha in this case? Anyone know? If I give you 94%, what is alpha?
0.06.
0.6.
0.06.
0.06.
Yeah, don't forget. Okay, so now what you do is you have to go to your StatCrunch. So now it's 0.06. This is what you do. You go to StatCrunch, you go to stats, you go to calculators and normal. Remember this one you did in chapter 6? The normal distribution?
Yep.
So 0 and 1, that is what you do. This one, you make it greater than, always greater than. This one, you leave it blank. This is the one that you use your alpha, 0.06, right? You say just now. But don't forget, you have to divide this by 2 because you got 2-sided. So whatever your answer came out, this is your answer. So your answer in this case will be 1.88. Okay, your answer in this case will be 1.88. Got too many windows pop up here. So this will be 1.88. You guys all right?
Yeah.
You guys want to try this? I'm looking for 93%. I'm looking for 93% confidence. So make sure you go to the calculator, normal, the one you did in chapter 6. And I want it in 2 decimal places. And do not forget to change it to greater than, don't put less than. If you put less than, you get a negative number. So make sure you put greater than here. Okay, this symbol. And it is in your notes here too. Anyone know as alpha in this case?
0.07.
But you have to divide by
2.
2. So your answer in this case is 1.81.
1.81.
Okay. You guys all right? This one I think we did before, right? I give you this 2 confidence interval. You need to find P hat and E. How do you find P hat in this case? I think this is the same question we just did over on your,
Upper limit plus lower limit divided by 2.
thank you so much, Gina. So yep, go ahead and find your p hat here. And then the margin of error E, you subtract and divide by 2, right? Go ahead and do this. This is not tough, actually. It looks tough, but it's not. Without StatCrunch, it is tough.
So it'll be 0.333 per p hat.
3, right?
Yeah.
And then, that's correct for p hat.
Oh wait. Negative 0.222.
Now, the reason why, Gina, you got negative is because you take 0.11 minus 0.55. Make sure it's upper
shoot,
minus lower. So what you do here, Gina, is you just ignore the negative and put 0.222.
Right.
Okay, because you do the other way around, so it's negative. You guys all right here so far? It's not, this is not that bad actually. Okay, so this is talking about identity theft. In a survey, they survey 1,082 people. 572 says yes, they are vulnerable to identity theft. Use a 99% confidence level. So do not click here. Don't look at this. This is, if you look at this, you are in the wrong class or in the wrong, you do not use StatCrunch, okay? So what is the best point estimate? So how do we calculate your best point estimate? So in order to calculate the best point estimates, which is the sample proportion, you have to take X divided by N. So what you do here is you take X divided by N. And they want in decimals. So go ahead and find the best point estimate here. Take this number divided by that number.
0.528.
Exactly 5.2?
Oh wait, 9. It'll be 9.
Okay, make sure you know how to round. So this is how you find your best point estimates. Is you take this divided by this. Now, how you find your margin of error? Because it's upper minus lower, right? But we did not have the interval yet, so we do the interval first. So how do we do the interval? Is you go to stat, you go to proportion stats, one sample with summary. What is the observations number of success we have here?
572.
Yep. And number of observation?
1082.
82. Now, I want to point out to you guys that this number of success should be less than that number. So if you got these two switched around, they will give you error. So make sure you just switch it back around. Okay. We are not doing this testing. We're doing confidence level. What percent of confidence level we're looking for?
99.
99. So don't use 0.01. If you use 0.01, you get everything wrong. Okay. So make sure you use 0.99 and you hit compute. Now they give you the upper and the lower limit. So can you figure out the margin of error in this case? What you do with these two? Subtract them and divide by 2. Now my question to you is, can you round this number to 0.57 before you calculate this? The answer is no. So you actually has to use all the decimal representation here. Okay. 0.567740007. Unfortunately, that's the only way I can tell. If you round this, you might get some problems with rounding error. So that's why I recommend you to use as many decimals as they can. And then divide this by 2. So this is what you get. In 3 decimal place, now you can round. 0. What?
039.
39. This one we already did it on your StatCrunch. So what is the number you put in here? That is your lower limit, and this is your upper limit. So we reconstruct the confidence interval here. So what is the lower limit in this case?
0.5.
For
Wait, what did I just say?
9.
Oh, yeah.
You're
Sorry. I
fine.
was looking at the
You're
upper
fine,
one.
Gina. 49 here, 490. And what is the upper limit in this case in 3 decimal place, the 1 decimal?
0.58.
568, right?
Oh my gosh. Yeah.
You're
Sorry.
fine, don't worry about that. I totally understand. You just got back from spring break.
For the margin error, you said you have to subtract the upper and lower limit.
And divide by 2.
Oh, okay.
Make sure you know you have to divide by 2. Don't divide by 2, you get it wrong. Now we need to figure out the confidence interval. So how do we interpret the confidence interval? If you remember this is in the notes again. So it's right over here. We are 95%. This is the interpretation. So which one fulfilled this interpretation? A, B, C, D. Anyone?
Is it D?
B for boy or D for dog?
D for dog.
D for dog. Can you do this?
I don't think it would be D because it says chance and we're
Thank you so much, Gina. You're correct. You cannot use chance. Yep.
B, because it also
B.
talks about population proportion.
Yep. B. It has.
And
Yep. So it cannot be C because of the word sample, right?
mhm.
So it'll be B for boy. You guys all right? So make sure you watch out for all these things. Cecilia?
No, please, can you explain the
Mhm.
C portion of it, please?
C
Yes, please.
is in your StatCrunch. Where's my StatCrunch? This is StatCrunch. This is your lower and upper here. So you go to stats, you go to proportion stats, one sample with summary. Number of success is 572. Number of observation is 1082. Then you click on the confidence interval and then they're asking for 99%. So you put 0.99 and you compute. This is this two, upper and lower and upper is your answer for C. Very important. Right, you do question number 7. They are the same type. Find the best point estimate in this case. What is the best point estimate in this case? And how do we find it? Is you take, there you go. They're hiding here. To find your best point estimate, you have to take these two. So can you tell me what is the best point and how do you find your best estimate here?
The number of successes divided by the sample.
And what is the number of successes in this case?
141.
And the sample size?
4,290.
Yep. Divide them and what you get?
0.032.
0.032. Okay.
Kind of
No, 0.033,
3.
right?
Yeah.
How you find E now? In order for you to find E, you need to take what? Upper minus lower divided by 2, right? But unfortunately, we don't have that upper and lower, so you have to use StatCrunch. Where did we go?
Per
Stat,
stat,
calculator, normal.
One no normal
one sample.
Oh, yeah, sorry.
with
summary,
summary. Number of success is what?
141.
And number of observation.
4,290.
And what confidence level are we testing?
I think it was
90.
90 is in the question. So this is your lower and upper. So how do we find your margin of error, E?
Upper minus lower divided by 2.
Yep, go and do it now. You need calculate. Can we go and answer?
0.00447773.
Yep, this, but I need 3 decimals.
Oh, 0.004.
Good. And your confidence interval in this case is already in your StatCrunch.
0.028.
0.028 in 3 decimal place. Yep. And the upper one?
0.037.
Yep. And the same thing asking you, what is the confidence interval? How do you interpret this? A, B, C, D.
B.
B for boy?
Mm.
Is that good?
I don't think it is because wait, aren't we supposed to not use the sample proportion?
You are correct. Log Gina cannot use sample. So B is wrong.
A.
It is A.
Whew.
Really read the question carefully. So
So for that part, I'm sorry, for that part, for D, we're just going off of the language that's
yes,
being used.
you are correct. We're going through the language as we use this
Okay.
one.
Could you explain what it actually means? Like for A, can you explain what it's saying?
The A
based on
part,
the math that we just did. Yeah.
this one, which part A here?
D. For D.
Why we pick
It was
A?
that A. Yeah.
So the language is this language.
Mhm.
So it means that the population proportion is actually falls between these two interval
Okay.
with
It
a
falls
95%.
within the-
Yep.
Okay.
With this confidence. Yep. So that's the reason why this is that's why, as I told you, this is something you need to write on the piece of paper
Mhm.
for your test, because it's exactly the same as this, because you cannot use the word chance and you cannot use the word sample.
Okay.
So those are the, yep. So it's kind of fixed in this case.
I see. Thank you.
So I want to point out to you that attendance, because it's almost time's up. So please, taking attendance right now. So mostly all the questions are asking the same thing. You can tell this is how many people, and then this is how many will do this. So one is X, one is N, and then they ask you for 90% confidence. So they're asking mostly the same type of questions. So that's why, but this one is special. I want you to read this number 9. Because the most important thing when you guys do this is, you need to know what is your X, you need to know what is your N, and you need to know what is your confidence level. So read question 9 here. And can someone tell me what is your X, which is the number of success, and is a number of observation or sample size? This is a special one.
272 is the successes.
Okay.
That means the sample size was 320.
No. Oh, yep. Oh, yeah. Sorry. That's correct. You're correct. Yep. Yep. And the confidence level.
99.
So you just put this in your StatCrunch and do it. How about number 10?
Um, 441 is the sample, then 161 is the success.
So X is 161 because we're looking for yellow, right?
Yeah.
That is correct. But N is not 441 because 441 is only green.
Oh.
What is N stands for?
The sample size.
Sample size.
The sample size. So how do you find your sample size in this case?
You add.
You add, because you have to add the green one and the yellow one. Yep. So this one is special because you do need to, they do not give you the sample size. They give you how many greens and how many yellows, so you have to add them up. And we still use a 90% in this case. For this case.
So the sample size is 602 then?
Yeah. Yep. Just use a calculator. Yep. This one is the same thing. Number 11. What is your X? And confidence level here. X is
132.
N is 400.
400.
The big number.
Yeah.
Big number.
420,002.
And it's 9. What percent is it? Let me see. They ask you for 95%. Now, just want to point out to you guys with this question, what is difference between this question and the other question here is this one doesn't have percent. You see that? But this question has what? Percent. So when you use your StatCrunch, if you get this, you have to multiply this by what?
100.
100. So let's say this is your answer. You should put 2.83 and then, and 3 point something. You guys with me here?
Yep.
So don't put exactly this answer in here. You will get it wrong because they want it in percent. Questions? They're all asking almost the same thing. Now, this one is very special. So read this question. This is the last question, actually, number 12. And tell me what is your X, N, and confidence level. Sorry. Anyone?
So 36. So N is 36.
N is 36. And X
And then
is
X is 6.
6. And the confidence level is
9.
0.9. And don't forget, this one once in decimal or once in percent as your answer. Percent. Okay.
Percentage.
Now, yep. Now, because it's given to you in the first sentence, right? What happens if this first sentence is not given to you? Can you still figure out your 6 and your 36 here? If the first sentence, yes. How you figure out 6 is you count how many candies are red. So if you count this, there are how many are red? 6. Is this number 0.712, 0.921? Are these numbers important?
No, that's weight.
Not, because that's weight. That's not important. We are talking about colors. We're not talking about weight. So how many red candies in this bag? There are only 6. And how many total? How you get 36? You just count how many candies you have. This is 6. This is what? 6, 7, 9, right? This is 9. This is 6. This is 8. And then this is 7. So you add all these candies out, you get a total of what? 36.
36.
So if you add 6 red, 9 blue, and add all this how many candies, and you will get 36 here. You guys with me here?
Mhm.
And then put it in your StatCrunch, and then you can run through to get the percentage. The rest is the same. This is all multiple choice. So try to do it on your own. This is not difficult, as you can tell, because we use StatCrunch. Again, if you do not use StatCrunch, it takes you 1 page to do it, to find these 2 numbers. So please use StatCrunch. Anyone have any questions for me? Because this is your homework due next Wednesday, 7.1. So make sure you guys try to do this homework. Anyone have any questions?